Hello and welcome to this video on the periodic table as part of the section on periodicity, and mostly this video is revision, so we've dealt with it previously in atomic structure, so we can go over what you need from atomic structure again now. And a couple of things that we need to do when we're studying the periodic table are how is the periodic table arranged? We're just going to recap on that. And secondly, what does the periodic table tell us about electron configurations? So they're the two topics that we're going to deal with in this video. But first, let's just have a recap of what you need to know from GCSE. So the first thing is, you'll remember that there are over 100 elements, all made up of atoms. Each element only has one type of atom. And they're in the periodic table. 92 naturally occurring, the rest have been made by man in lab. And then we've got groups in the periodic table. They're the vertical ones on the periodic table. And of course we've got periods, which are the horizontal rows. And the groups are groups of similar elements of similar properties, and the periods all have the same number of shells. And we know from GCSE that metals are on the left-hand side. They're about 2/3 to 70% of the elements in the periodic table. Whereas on the right-hand side, you have the non-metals. About 1/3 of the elements are non-metals. And we can say something about the properties of an element. And we know that those properties depend on things like atomic radius and how many electrons are in the outer shell. So a property such as reactivity, for example, depends on its atomic radius, because atomic radius influences how much attraction there is between the nucleus, which is positive, and the electrons, which are negative. How many electrons are in the outer shell also influences the properties. If you've got not many, then the element tends to want to get rid of those electrons. And if you've got a nearly full outer shell, then the element wants to quite aggressively fill up that outer shell. But if it's full, of course, then it's not reactive at all. And lastly, there are trends in the properties of the elements, both going down a group. In GCSE we did group 1 and group 7, and we had a look at things like reactivity trends going down the group for those two groups. And also at A level we're going to study how those trends trend across a period, particularly period 3. Okay, so that's what we should know already from GCSE. Yes, so you remember here that the first lesson objective was to figure out how the periodic table is arranged. And here we have the periodic table that you'd be familiar with. And the first and most important thing to realize is that the elements are ordered in order of their proton number, their atomic number. So hydrogen comes first, proton number 1, helium second, proton number 2, lithium proton number 3, beryllium 4, etc., right down to the end. So that's the first thing. And the second thing that we're going to remind ourselves of in this lesson is that in periods, they're the horizontal ones, and we're going to have a look at period 2. All right, and here we've got lithium. In period 2, there are 2 shells. All right, so we've got here, it's the first shell, and we've got here, which is the second shell, and all the elements in period 2 have 2 shells of electrons. So we can look at another element, beryllium, just one along. You can see that whereas lithium has 1 electron in its second shell, beryllium has 2 electrons in its second shell, but it's still filling up the second shell. And then, for example, boron, the next one along, It's got 3 electrons in its outer shell, but still 2 shells. So, and that would be the same trend as you go all the way along period 2. So the period number gives you the number of shells. You could also call the period number the principal quantum number. Okay, next thing is going down a group, right? So if we started in group 1 with lithium, you can see we've got 1 outer electron, and it's in group 1. Alright, and then the next one that's just appeared there you'll see is sodium, and that has 3 shells, you see. Got first shell, second shell, third shell, and you notice over on the left there that it's in period 3. But it's also got 1 electron in its outer shell because it's in group 1. And you'll see the same pattern there for potassium. Potassium's in period 4, 4 shells, and just the 1 electron in the outer shell. So that's the last thing about how the periodic table is arranged, where you've got number of outer electrons is the same as the group number. And just to clarify, group 0, sometimes called group 8, it's because there's 8 electrons in the p subshell in the group 8 or group 0 elements. And if you were looking at the next shell, there would be 0 electrons in that shell because the previous one's full. Okay, so that's that one. Let's move on. So now we're moving on to the other learning objective, which was this question here: what does the periodic table tell us about electron configurations? And this slide, this little bit of learning, is mostly about subshells. You remember that subshells, we get S subshells, right? We get P subshells, and we get D subshells, and actually we get F subshells as well. So each of the main shells are split into subshells, and the subshells are either S, P, D or F. So let's have a look at the periodic table, and you can see this periodic table here is split into blocks, and this block here is called the S block, and that's because the outermost electron of these elements is going into the S subshell. Okay, so if we take an example, take lithium for example, the electron configuration of lithium is 1s2, 2s1, and so this is the outermost electron, and that's in the S subshell, and so that's why that's in the S block. Okay, let's take another example for the S block. Let's take magnesium. So the electron configuration of magnesium is going to be 1s2, 2s2, 2p is full, so 2p6, and then it's got 3s, and it's got the sodium is 3s1 and magnesium is 3s2. So there we go. The outer electron of magnesium is in the 3s subshell, and that's why it's in the S block. Okay, we could use another example. Let's take boron for example, just along here. Electron configuration of boron is going to be 1s2, 2s2, both full. All right, and then you're going into you're starting to fill up the 2p subshell, and the electron, boron's outer electron is the first electron in the p subshell. So that's the electron configuration of boron, and you can see the outer electron being in the p subshell, so it's in the p block. Maybe we'll do one more example. Shall we do chlorine? Let's have a look. Here's chlorine, and so the electron configuration of chlorine, very quickly: 1s2, 2s2, 2p6, 3s2, all full up, and then in 3p we've got 1, 2, 3, 4, 5. So 5 electrons in the 3p orbital. 5 and the 2 3s electrons making 7, of course, so that's why it's in group 7. but the outermost electron is in the p subshell, and that's why it's in the p block there. So when it comes to period 4, this period here, potassium and calcium, it's potassium and calcium there, they're filling up their 4s subshell first, and once the 4s is full, then scandium comes along with its extra proton there, 21 protons, and the next electron there is actually going back into the third shell in a subshell called the D subshell. Okay, so the all the D block, that's a whole lot from here, their outer electrons are starting to go into the D subshells, but interestingly notice that it's in the previous shell to the fourth shell that has also already started to be filled up. So that's the D block, outer electrons going into the D subshell, and then it's worth noting also the F block, which sort of fits in here. They're called the lanthanides, and so there's another subshell called the F block, which at A level we don't study at all. At A level we study just out of krypton, so we don't have to worry too much about the F block, but just to say that it's another subshell that exists in very big atoms. Okay, lastly, just an interesting little picture here of plutonium. This is plutonium that is actually glowing red hot, heat coming from its own radioactivity. Plutonium is only a tiny amount on Earth. It's only created when uranium decays. So the element that is usually described as the heaviest naturally occurring element is uranium. But you do get a heavy one in plutonium, which exists only temporarily because it's very radioactive itself when uranium decays. So let's just check that we've done our lesson objectives. How is the periodic table arranged? Well, you remember that it's arranged in order of proton number or atomic number, and group numbers, number of outer electrons, and period numbers, number of shells. Okay, so, and what does the periodic table tell us about electron configurations? Well, it's split into blocks. The blocks are determined by the subshells, and the subshells tell us what subshell the outer electron is going into. So there we have it. That's about all that you need for this little topic, and it tends to be that the only exam question you get specifically on this is naming what block a particular element comes into, so which will be fitted into an exam question on another topic. Okay, I hope you've understood that and that was all clear. Thank you very much.